So first of all, hello everyone and welcome to our webinar today. My name is Florian and I'll be the presenter for this webinar. And just a quick note before we begin, this webinar will be conducted in English as we have an international audience. So today's webinar is about Twyn, our augmented reality-based quality inspection tool. And before we begin, first I would like to introduce our company Visometry. So we were founded 5 years ago as a tech startup from Fraunhofer Institute in Darmstadt. And since today, we are a team of roughly 30 enthusiasts and experts in the field of augmented reality. And besides our new product Twyn, we also have the well-known product VisionLib, which is an object tracking SDK for AR. Which is ideal for maintenance purposes, training, production, and marketing. And we are with this product since years on the market. So we have a lot of registered developers and over 200 paying customers. And VisionLib is supported on iOS, Android, HoloLens, and Windows. So this is the ideal solution to develop your own custom AR applications, and Twyn is more an off-the-shelf product, which will be presented in the next slides. Yeah, through the research projects at Fraunhofer and from the feedback from our VisionLab customers, we have recognized an increasing interest and the usability of our technology for the area of maintenance and inspection. And the share of analog processes stood out in conversations with the customers. So nearly 60% of the manufacturers are still using a manual or analog inspection processes in their production processes. And if we look at the currently established inspection systems, there are mainly two. On the one hand, non-digital inspections, which are mostly paper-driven, and on the other hand, really precise but really elaborated processes like 3D scannings with a measurement arm, faro scanners, and something like that. And those both approaches have some disadvantages, especially if we consider a large number of product variants in the automotive, aviation, or in the machine construction side. And for the other hand, there's a high risk of consecutive manufacturing errors and followed by follow-up costs in the production because you can't give assemblies into a subsequent production step, for example. And of course, we have really high costs for the quality assurance, which prevents 100% control. That's the reason why you only have this, how to say, only the sample rate, which is, of course, much lower than the 100%, which would be the ideal word. So, and the metrology systems deliver a really high precision, but they are really time and setup intensive. And of course, really expensive. Imagine the costs of a faro scanner or a measurement arms are increasing, really, really high. And another disadvantage, of course, is that you are location dependent. That means you always have to bring the object to be inspected to your measurement arm, to your metrology department. That is a really great disadvantage. So that's the reason why we introduced Twyn as an augmented reality-based quality inspection system. And one hint, Twyn is not a metrology system. It's an inspection system. So it won't make your measurement arms and your metrology department obsolete. So Twyn will be more a companion to your established processes. So to summarize, while traditional measurement and inspection methods can be costful and really time-consuming, Twyn streamlines this process remarkable. So by overlaying the digital information onto the physical world, Twyn provides a direct and intuitive comparison between the expected or as planned against the as is or actual components, and making discrepancies immediately apparent and reducing the margin for errors. So this not only simplifies the alignment process, but also enhances accuracy and efficiency. So the great benefit of Twyn is that you can drive or execute inspection process in real time, just in place of the object inside the production line. So you don't have to bring the objects to the inspector. The inspector can go with Twyn to the part to be inspected. And it's really user-friendly, so it's a really intuitive software. So also only a minimal training is required, which is also a great benefit against metrology and the used software in this field. And Twyn can be used by metrologists, but also by suppliers and even by workers who are pretty familiar with Twyn after 1 or 2 days working with the system. And Twyn allows you to check the correct placement of geometric features. We will consider this topic in the next slides. And as I mentioned before, it's more a companion to the metrology approaches. So if you find a deviation with Twyn, you still can give the part to the metrology department so that they can scan it in really high precision to determine, for example, where does the deviation come from. Yeah. And additionally, it ensures that no missing parts are in your assembly, and all the components of an assembly are placed or installed properly. So to summarize, the great advantage of Twyn is, for the one hand, the really quick setup and therefore to save time, because for the most simplest use case, you only have 3 steps to set up a project. So basically, at first, you just load your CAD file. We support the most common industrial CAD formats. You will find further information about the formats on our documentation. In the next step, you only need to set up some initial pose where the inspection starts from. And basically, that's everything you have to take care about augmented reality and especially of object tracking. So we reduce the complexity of tracking remarkable. And when you set up your inspection project, you can just deploy to your iPad. You can even deploy to multiple iPads. And of course, you can deploy multiple projects at once on one device or multiple. And therefore, we can achieve a really high efficiency, as we can execute inspections much faster than the paper-driven and established processes. And therefore, we increase the sample rate, so you are able to inspect much more parts against your past processes. And this leads into a really high grade of flexibility, as we mentioned that you bring the device to the object to inspect. So you can even inspect parts which are still on a truck, for example, or which are outdoors or on the shop floor. It's up to you where you execute the inspection. And if we compare it against the past, the inspection processes of our customers were mostly complex and fragmented. This means if we consider this past process chain, people have to take care about collecting data. This could be the 3D data, the inspection plans. They need to prepare the job. They have different input, for example, a Word file, Excel, PDF. So they have to collect all these data together in order to set up an inspection process. And after the inspection process, they have to take the results into reporting data. We saw that, for example, a lot of customers put it manually into an Excel sheet, and after that they share the files in different versions, not synchronized to their suppliers or to their construction department. So that's something we totally changed with Twyn, as it's digital by design quality inspection process. So this means from scratch you start digitally, from loading your CAD data, set up the inspection process or the inspection routines inside Twyn Studio, also an inspection authoring platform. Then you transfer to the iPad, do the inspection on the mobile device supported by AR, and find deviations really quickly, and the report is automatically set up in behind for you. So this makes it much more easier to share the result or the report of the inspection to your suppliers and colleagues, but we will consider that in the subsequent slides. So this mentioned process is applicable for mostly all of those industries you see on the left hand here. So we have over 120 customers for Twyn in those segments, for example, from the automotive section, the aerospace, aviation, heavy equipment, manufacturing, large machine parts and castings, or even for constructions. And all for those industries, they have common use cases. So it's every time it's about assembly support, quality gates, incoming, outcoming goods inspection, design evaluations, body in white validations, and much more. And the use cases are still increasing every time we get new ideas from our customers. So we want to showcase some representative use cases in the next slides and show the benefit of AR, especially in those use cases. So let's start with the automotive sector. For this use case, Twyn is especially suitable to check the geometric features of a body in white. This could be that you're checking joining technologies, for example, like checking the welding points, bolts, or studs on the body frame. And the great advantage with Twyn is that you immediately see and check, for example, the number of parts or the absence of parts. Are parts assembled at the right position? You can check if there's a damage, for example, if somebody's bended over, or the condition of the part. And you can even simulate subsequent assembly steps by do some virtual fitting, as we can track the object, and in this case, it's a door of a car. And with AR, you can augment virtual objects into reality. So by doing so, you can check if, for example, a part can be assembled in a subsequent step. Then it's also really useful in the field of tool making. So tools are really crucial for efficient machining and assembly, and therefore it requires a really or it ensures that the parts which are machined needs to meet specified requirements, and this is achieved by building tools. But somebody needs to check those tools as well, and that's where Twyn is really beneficial. As Twyn allows you to track on the construction data in real time. And this allows you, or it's really perfect, especially for small batches, or if you have some prototypes with a lot of design revisions, where you just change the data in the background, and Twyn allows you to utilize those CAD data to track the object and check it for deviations in real time. So the great advantage is that you have a 3D to 3D matching, which allows you to check if all parts are assembled at the right position. And this also works for really large parts or assemblies We even tracked parts which are over 10 meters large, which is basically no problem for this technology. Imagine doing the same with a faro scanner or with a measurement arm, which is basically impossible. So the next scenario are jig and fixtures. So there you have to ensure the position or the orientation of multiple parts, mostly a vast number of parts, and they can even movable. And those fixtures are also crucial in a manufacturing process. And of course, they need to be accurately positioned and aligned, especially if you use it, for example, for welding, for body in whites. And even for that, AR, and in this case, Twyn, allows you a real-time alignment check and adjustment check. So you immediately see in the augmentation if a part is missing or if a clamp is misaligned. And of course, this prevents really costly reworks and errors due to downtimes in the production. Another really famous use case for Twyn, that's also a use case we started with, is the incoming and outgoing goods inspection, where you have where parts frequently are delivered by suppliers, and you have to check them by the geometric specifications. And for this, you can set up inspection schedules or inspection procedures, which have only an initial effort to set up. And you can execute those projects every time a part comes into the incoming goods. And you can check the part for possible deviations. And the great advantage is that even the suppliers can verify their manufactured parts against CID specifications, and they can rework parts even before they are sent on the truck to the customer. And the great benefit, of course, is even in this use case, that by identifying possible deviations at an early stage, you prevent production errors also at an early stage in the process chain. So that are some exemplary use cases we address with TwinView, but we're also excited about your ideas as customers, what you can do with Twyn. And in the next slides, we want to go through the highlight features of our newest Twyn 2.0 release, which was released in summer this year. And for those who are not familiar with Twyn, TwinView is the one part which runs on the Apple iPad, and Twyn Studio, which is the authoring platform to set up the quality inspection procedures, is available for Windows and for Mac as well. So one highlight feature is the flexible import and export capability. This means that you can share the inspection process across locations with your colleagues and with your team. So this means that you can have multiple instances of Twyn Studio at different locations, and you can share the same project. And this is also the case for the transfer to the iPad. So you can export your inspection processes from Twyn Studio to your iPad by cable, but also remotely by mail, by Microsoft Teams, or by cloud. For example, OneDrive works pretty well. And this remote project transfer eliminates redundancy and duplications, and you can even share projects with your suppliers in other countries. Then we also included an embedded model preparation mode. So because this was something really disadvantage in the prior process change of mostly of our customers, because inspection are basically a really time-consuming, costly procedure, and it requires multiple softwares, which also are really costful, as you have to pay for the licenses. And imagine you need to prepare CAD data in order to utilize them in a quality inspection. You needed a third-party application to prepare those data. And with Twyn, we eliminated this disadvantage as we included this embedded CAD model preparation mode into Twyn Studio. And it allows you to prepare or simplify and optimize your CAD structure. Mostly the CAD structure contains much more data and structure as actually is needed for the inspection. And with the model preparation mode, you can extract only the parts which are really crucial and essential for your inspection process. And furthermore, we also optimized the CAD data for the usage on the mobile system, so you doesn't have to take care about the complex process of optimizing 3D data. Everything is done automatically for you. And this leads into the benefits that you have a much faster and streamlined quality inspection process, as this is an embedded part of the data preparation. Then, yeah, nearly the most important highlight feature of the last release is the automatic part inspection. So the key features are that you can set up replicable inspection plans in before for your inspection procedures, and you can define which of those parts needs to be checked in your inspection routine. And you can do it manually by yourself, so the inspector can find deviations by himself, or Twyn can also assist you by classifying and verifying parts automatically. So if you define parts which needs to be checked, Twyn automatically recognize if those parts are assembled at the right position, or the absence of the part if it's not there. So then we have those inspection points here, which turn red if the part is missing or at the wrong place, or it turns green if it's there and assembly in the right manner. Yeah. So, and this leads to an instant and a clear outcome in the process of finding deviations. And you always have interactive guidance. So Twyn always shows you the unfinished inspection points, so you will never forget any points in your inspection routines, because we have some checklist-based principle. So behind every inspection point, you get a check mark or a cross, which indicates the result of this inspected part. So the great benefit is that you achieve a really quick and still precise inspection. So Twyn achieves up to 1 millimeter precision, and it dramatically reduces the risk of incomplete checks, as we have this checklist-based principle, like I mentioned before. And here's a small video on how to illustrate this new feature. As you can see, this is the underbody of a car frame, and we automatically check those bolts if they are existent, or if they are placed at the right position, or even welding points can be checked. So as you can see, the red ones are placed at the wrong position, as you can see here. And this simplifies and assists you in your inspection routines. Then a clear and unambiguous CAD visualization is also really crucial to find deviations. That's why we improved the visualization in the last release. And from now we support displaying CAD colors in both platforms, so in Twyn Studio and in Twin View as well. and you can decide if you want to work with your predefined model colors, or if you want to use the predefined CAD colors, or you can even differentiate between parts by setting custom colors, or you can also adjust the color, the width, and the intensity of the contour visualization. And this is beneficial, for example, in the use case in the automotive sector, where you need to differentiate parts against or to compare nominal data against actual parts. And you can even convey extra details like materials, as materials are mostly color coded, and therefore you can differentiate between parts by the augmentation. Another feature is the pause and resume feature, which allows you a flexible quality inspection schedule. This means that you can start and pause and even resume your session at any time without any data loss or negative impact on your previously captured data. And the benefit is that this feature assists your company in planning and executing your inspection. This means if you have a really complex and really big inspection, you doesn't have to take care that you start in the afternoon. You can just leave the inspection and proceed it in the next morning. So this feature tailors your organizational needs. Furthermore, we have some more tools which also assists you in finding deviations. On the one hand, it's the lens tool, which allows magnify regions which are, for example, ergonomically not reachable, or if you have an object which is low structured, which is not really suitable to be tracked, then you can track the part at a self and just magnify the region you are interested to without losing the tracking. Then we have the clipping tool, which allows clipping the augmentation against the reality, and therefore it allows a really easy A/B testing. So you can check if there are holes in the CAD model which are absent in reality. And furthermore, we also have annotations which are really suitable to enrich the object with additional metadata, for example, names of parts or joining technologies or whatever of metadata you have in your company. And of course, after the inspection, you want to share the results of your inspection. And that's why we introduced the possibility to share your inspection reports in different formats, for example, Adobe PDF with images, or Excel file, or as a CSV file. And you can share those different report formats via different platforms. It's the same like the import of the project, as you can import it via cloud or Teams or mail. It's also possible in the opposite direction, that you can share it by the same platforms. And the great benefit, of course, is that you can share the data between your stakeholders, regardless of your IT setup, as we figured out that mostly one of those platforms is already existent in most of the companies. And a small feature, to be honest, but we also included German language support for the user interface of Twyn View and for the reporting language. So you can even decide if you have, for example, some German field workers who needs a German UI, but you need to share the report to some English speaking supplier, then you can switch it, and we will support additional languages in the near future as well. So let's come to the summary of this webinar. So Twyn basically delivers you a digital test system which allows to set up inspection routines and do some interactive target and actual comparison of your CAD data with augmented reality. And the great benefit is everything just works on the geometry data. So there are no markers needed. There's no teaching process needed. This means if you have any design revisions in behind, just change the data, and then you can start immediately with no setup time, basically. And another great benefit, of course, is that the system runs on consumer hardware. So you just need an iPad Pro or an iPhone Pro, and then you can start inspecting your parts. And it's a really efficient system which assists you by step-by-step control. So even if you have some additional instructions, they can be displayed in Twyn, so you assist the inspector over the whole routine by giving him additional information as well. And as a result of the inspection, Twyn delivers you an instant documentation and the sharing of the reports with your colleagues. And so to be summarized, you get a really great time saving thanks to the help of augmented reality, and you get a really lean process. So as we digitalized the complete inspection process from the setup even to the inspection and to the retrieving of the inspection reports. So if you're interested and you're still not a customer of Visometry, we kindly invite you to test Twyn by yourself and convince you about the quality of the software. And we can even set up a call or on-site demo with your own data to set up an inspection process. So if you have any questions, here are my contact data, or you can even contact our head of sales, Ulrich Bockhold. And we are now at the end of the webinar. If you have any questions, I'm happy to answer them.
Please put them in the FAQ. Like we have currently 2 questions.
The first question, yes, you can utilize the metadata. You can even type them by your own if you set up annotations in Twyn Studio, and then those metadata are displayed in Twyn View. Or we will also introduce in the near future the ability to automatically set up your inspection process. And if you already have inspection routines digitalized and you have those metadata available, you can also use this data to enrich the inspection. And then we can use those metadata, and you can decide which of those metadata should be used for the annotations, and therefore you can use them in Twyn View on the mobile device as well. And this, of course, implies, for example, the name of a part or joining technology or something else, which I already mentioned in the presentation. We have another question: how to handle modules, fuses, switches, cabinet you buy in and have no CAD data, no complete digital twin. Basically, the principle of Twyn is that you compare the as-is against the as-is state. And CAD data is crucial to do this quality inspection. So if you have something which is not in your CAD data, we can't compare it against the constructional data. So in this case, we thought about capabilities. For example, if you scan something, for example, the iPad also have this built-in LiDAR laser scanner, but in the current version of the device, the precision is not really suitable for this use case. So I'm afraid that we need the CAD data to do the comparison. We have another question: what is the accuracy of the 3D overlay on real object? The precision depends, of course, because of the distance of the camera to the object. So imagine the camera of the iPad has some resolution, and if you are, for example, 20 meters away from the object to distant, you can't achieve a millimeter precision. But if the object is well structured and you are close to the object, then we can achieve a millimeter precision. Any other questions? What is the approximate investment cost? Yeah, it depends how many devices you want to license. So basically for license costs, please contact Uli Bockholt from the sales team. But maybe Tobias, you can give me the actual license cost for one setup.
Yes, sure. Like one setup will cost like 5,100, and then you get like the authoring system and the viewing app. So you have like the base system, and from there on you can add more, for example, like viewing apps if you want to send it to like suppliers, or if you need more in-house, then you would also need the authoring system.
And of course, you need an iPad Pro device by yourself. But basically, that's everything you need to start. And let's switch back to the FAQ. Will there be an Android or Windows version? Currently, we only support iOS because the calibration of the camera on the iOS device is best in class, and you doesn't have to take care about camera calibration or all the stuff. And even the sensor fusion is best in class on iOS devices. That's why we focused on this platform. But for the future, we will see what happens. Is the accuracy of the overlay on the CAD part affected by features not in the CAD? For example, the sub-assembly being held in the clamping fixture, not CAD. Yes, as the basic principle of model-based tracking is that we use the CAD data as a reference file. The reference part which is used for the inspection needs to be precise, and this implies that it has an effect on the precision. So imagine if you want to check a part and you have a reference part which differs to the construction data, then it has a negative impact on the precision of the tracking. So in this first phase, you have to select the parts which needs to be automatically inspected by yourself in Twyn Studio. But this routine is mostly a recurring inspection. So you only have those efforts initially, and after that, you don't have to define anything by yourself. So that's the requirement currently for the automatic part inspection. But of course, for the near future, we are also considering more elaborated technologies on how to check a part for possible deviations with less effort on the authoring side. Yeah. But currently, you have to define the parts which you want to check by yourself. If you still have some questions after this meeting, you can still write me an email, or we can also set up a Teams meeting where we can answer your questions. And if you go on visionlab.com, there you will see further details about VisionLab by itself and also about Twyn. And it also guides you to the documentation of Twyn, which is also a good starting point if you have some detailed questions.
Hello everyone again. So we're going to like do a quick touch up and cut the recording session. And once this is done, I will send you all an email with a download link to the session. And I'm going to use the same email you used for signing into the session.
Okay, then thank you very much for your attention. I hope we will be in contact after this webinar. If you have any questions, we're glad to answer them. Bye, have a nice day. See you.